Chapter 9, Question 3 says water is a polar solvent, carbon tetrachloride, CCl4, is a nonpolar solvent. In which solvent is each of the following more likely to be soluble? And that's the key word here, solubility. Something is soluble when it dissolves in something else. So when you put table salt in water, it dissolves, and so that table salt is soluble in water. But if you were to try to put a rock in water, it may not dissolve, and so it wouldn't be soluble. So here we're trying to predict whether things are going to dissolve or not. But they're things that we may have never heard of before, like carbon tetrachloride and sodium, or NaCNO3 in A, for example. So how can we reason through this? What's a general principle that will allow us to predict whether something will dissolve or not, even if we've never run into it before, we're not familiar with it? And the big principle is that like dissolves like. Now, when they say like dissolves like, what I mean is that polar compounds will dissolve in polar solvents. So polar solutes will dissolve in polar solvents, and nonpolar solutes will dissolve in nonpolar solvents. Remember that polarity is caused by differences in, and the jargon term is differences in electronegativity. Electronegativity increases as you go up and to the right on the periodic table. It tells you how much an atom attracts the outermost electrons around it. So in nitrogen, oxygen, fluorine, and chlorine, which are in the top right of the periodic table, those are really electronegative. So they pull electrons to themselves and become a little, that's what this squiggly lowercase d is, a little negative. And whatever they're bonded to becomes a little positive. So the bonds have two ends, a negative end and a positive end. Another word for ends are poles, and so the bond is called polar. So compounds are polar when they have nitrogen, oxygen, fluorine, or chlorine in them, or else just have a really big difference in electronegativity. The principle is profound. Not only does it tell you whether things dissolve or not in other when they're put into other liquids, as we'll see in a second, but ultimately it's responsible for how cells are organized, and how your body transports the things that you eat. So it's a profound principle that will come back again when you look into biochemistry. Okay, so they say that water is polar. And this other thing that we may have never heard of before, carbon tetrachloride, CCl4, is nonpolar. Carbon tetrachloride is a slightly sweet smelling but also slightly toxic compound. Looks like water, it's a clear liquid at room temperature. All right, so we have these two different compounds, and what we want to know, it says in which of those solvents is the following more likely to dissolve or be soluble. Now, there is a sort of disguise here. Ionic means that you have full charges. So the sodium has a full positive charge, and the nitrate, the NO3, that's a polyatomic ion, it has a full minus charge. That's what makes them ions. Ions are things that have full charge. Now, that clearly is polar. It has two ends, or two poles. A positive pole and a negative pole, so that is very polar. So whenever you see ionic, you can cross it out, and in your mind you think polar. Okay, well if we know that that's polar, what will it dissolve in? It will dissolve in water, because water is polar. So this would dissolve in water because like dissolves like, and both water and here, the sodium nitrate, NaNO3, are polar. Okay, for B, they say that the compound is nonpolar. It says I2, it's nonpolar. So what will it dissolve in? It will dissolve in the carbon tetrachloride, CCl4. How do you know? You may have never seen solid iodine or gaseous iodine, and you may have never seen carbon tetrachloride. So how do you know? You know because like dissolves like. Profound principle. And both the I2 and the CCl4 are nonpolar. Okay, how about for C? In C, it says sucrose, that's table sugar, is polar. So what will it dissolve in? Water. Why? Because sucrose is polar, water is polar, and like dissolves like. For D, it says gasoline, and they tell you that gasoline is nonpolar. So if you pour gasoline in water, will it mix? No. It would mix with a nonpolar solvent, like carbon tetrachloride. So like dissolves like. You can't mix a nonpolar thing with a polar thing. So gasoline would dissolve in or be soluble in carbon tetrachloride, CCl4, because like dissolves like, and both gasoline and CCl4 are nonpolar. Now question 4, or exercise 4 in chapter 9, is pretty much the same thing. They tell you that water is polar, okay, we knew that, and then hexane, this thing we may have never heard of before, is nonpolar. Hexane, another clear liquid, creates another vapor that you can definitely smell. A room full of people working with hexane will smack you in the face. The smell of it will smack you in the face if the people aren't underneath a fume hood that sucks up all the vapors. So it says, in which of these solvents would the following more likely dissolve? Okay. Well, the first one is vegetable oil, and they tell us that it's nonpolar. Well, that would dissolve in hexane. Why? Because like dissolves like. Oops. And both are nonpolar. So actually, let me do this, and then I will take this, and just here in this problem, they're using hexane instead of carbon tetrachloride. So vegetable oil would mix with this hexane because both of them are nonpolar. How about B, benzene? They used to use benzene to light up street lamps in the 19th century. Now, you'll find benzene as a component in a lot of pharmaceutical drugs and a lot of natural compounds, like things that cause the smell of mint. They say that benzene is nonpolar, so what's it going to dissolve in? It's going to dissolve in the hexane. Why? Because like dissolves like, and both are nonpolar. Actually, that's one of the ways that you can get different compounds out of plants. If you want to separate, say, like the mint oil out of a mint plant, you can dip the plant into something like hexane, and all the nonpolar stuff in the leaf will mix with the hexane. All the polar stuff will stay in the plant, take the plant out, and now you have the oils in that plant, like things that cause the smell of mint, mixed with the hexane. So like dissolves like. Benzene is nonpolar, hexane is nonpolar, so that's how they're going to dissolve. Now remember, in this next one they give you LiCl, lithium chloride. It's a white solid, it would look like table salt, and they tell you it's ionic. Remember that ionic is polar in disguise. It has the ionic means you have a full positive charge on one of the elements, full negative charge on the other, and those create two ends or two poles to the bond that's making them stick together. So it's polar. So if that is polar, what will it dissolve in? Water, because water is polar and like dissolves like. So we can take that up here. We've seen this line of reasoning before. Water, because like dissolves like. So we may never have heard of lithium chloride, but we know if we put it in water, it's going to dissolve. Finally, Na2SO4, that is sodium sulfate. And they want to know if that would dissolve in water or hexane better. Well, it's ionic, and again, like we saw, that means that it's very, very polar. And so, because it's polar, it will mix with the polar thing, which is water. So, this compound, sodium sulfate, Na2SO4, that would dissolve better in water because like dissolves like, and both are polar. So, something to take with you for the rest of your life. How do things mix together? Like dissolves like. If they're not both polar or if they're not both nonpolar, they won't mix with each other. It's a principle of organization for anything that comes together, especially for living things.